Hi, it's repair time. This one's from home. It's my old Goal Zero Yeti 400, as the name suggests, 400 watt hour battery. It's one of these, little portable things. We use it to take camping. We just used it like 6 months ago for camping. It's been working great for years. You might have seen this in one of my second channel videos. This one actually powers my solar assistant Raspberry Pi from the USB output here. And that does all my solar monitoring from the DI inverter. And well, I've got to admit, it looks like I've goofed it because this thing ordinarily powers that Raspberry Pi, but I was mucking around with my solar setup at home, and I actually, like normally it's powered from this external plug pack here, which can power from external solar panel up to, never exceed 22 volts input here. This is like a 16 volt plug pack, and it's normally just floats at 100% there. And unless we want to actually take it somewhere and use it, and it powers that Raspberry Pi. But unfortunately, I was mucking around with it and I accidentally disconnected the mains to it, so my Raspberry Pi solar assistant worked for like a week or something until it suddenly stopped working. And I was checking my solar thing on my shoe phone, and it's like, oh, it's not talking. Oh, it might need to reboot it or something. And I went out there to investigate, and sure enough, this battery was completely flat. Wah, 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 wah. And this is what happens when I plug it in. Watch this. Hopefully, you'll see there's an input LED here, and you might see this screen actually light up briefly, and this LED comes up. It flashes off, and it looks like it doesn't charge at all. So it looks like it's drained to a point where it can't charge anymore, which is a design oversight of this Goal Zero. Yeah, you saw it actually flash again. It sort of periodically does that, but I've actually left it on there for many days, actually, hoping that it'll just eventually recover or whatever, and it doesn't. So, yeah. That's a bad design. Yep, there we go. It just hiccuped again and tried to start, but as I said, left it there for days and it doesn't seem to overcome this. So it looks like the internal batteries have drained to a point where it just can't start up and the charging system or whatever, and it just doesn't recover. So it basically killed itself by letting itself run flat, which is, dumb. This is like a really old model. I don't, it's not current. They've got several generations beyond this one now. But it's always been a good little unit. But I've never actually let it drain down to absolute zero before. So if it's some other fault, it's a genuinely huge coincidence. But no, I think I did it by just draining this thing, sucking, a couple of watts out of here to drive a Raspberry Pi, leave it running for a week, and eventually, wah, 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 wah. Anyway, let's see if we can open this thing. So I am actually down here in the dungeon because I don't want to work on like relatively high capacity lithium ion batteries up in the lab. If a fire happens, I do have my fire extinguisher down here, and there's no fire sensor down in here, so I'm not going to get an $1,800 bill. I am using my Swiss Tools set. Somebody personalised this for me, sent it into the mailbag like a donkey's years ago. Let's crack into this thing. I don't think I've ever done a teardown of this. Oh, that's plastic. Sure enough. It's the handle. Oh God, I was fooled. There you go, lift that up. Oh, that didn't make sense. So yeah, they molded that in there just to confuse me. So yeah, I might have just opened this up. Well, yes, I might have opened this up myself once, but I've never. Oh, that's nice. That just comes off. There's nothing in there at all. So, yeah, I don't think I've ever done a teardown video of this. Let's have a squiz. Well, that looks pretty neat, does it not? I don't have my regular poker here. It's gone missing, but yeah, we've got our big heatsink along there. We've got sill pads there for our drivers, and there's another couple of devices down there with some sill pads. Anyway, this looks pretty neat. That's interesting. Input blade fuses there. Didn't expect to see those, but I guess that makes sense. Anyway, that's obviously coming from the battery. Look at that, big and beefy. First thing I can do is actually measure that pack and see what it is, because probably the easiest way to fix this would be to use an external, disconnect all of this from the battery and then sort of like slowly trickle charge the battery from an external supply and get it back in business, because I suspect that's what's happening here, is that it's just drained to a point where it doesn't have enough startup voltage to start up, and some protective thing is kicking in, and it's just badly designed in the sense that it allowed itself to actually drain below a point where it would actually start back up. Got a fan on either side here, which is pretty decently designed. So, it obviously sucks in one side and blows out the other. That's what she said. Those caps don't look special at all. Sorry, this is not my best camera. This is not my best light down here. So this board looks like just the 240 volt mains inverter for it. So we've got the battery coming in here, and the output, the 240 volt output goes over here to the main socket on the front down there. It's only got like, it's not huge power. What is it? 300 watts, 1200 volt surge. It's good for like little fridges and stuff when we're out camping, and lights and other sorts of things like that. But nothing serious. You're not going to go out there and use your power drill with it. And we've got another set of beefy red and black wires coming from the battery pack down there up to this main controller board up here. So it looks like two different heavy duty wires coming from the battery pack down there. I was hoping not to have to take this completely apart, because the battery pack's like down in here. I'm sure it's all messy to kind of like, although it looks like, yeah, I can get there you go. I can just lift out the front panel there. That's pretty good. Well, there you go. Look at that. Oh, are they inline connectors? We've got our rechargeable lithium ion battery. There it is. Aha, found my yellow poker. I knew it was down here somewhere. So those two big ass battery wires, they're just soldered directly down in the PCB there. They're thick as. Got some switching transistors there. And, well, there's not much else doing. There's a processor on there, as you'd expect. That's driving all the front panel LCD, and it looks like it's just, powering like the USB outputs and stuff like that. We've got a cigarette lighter input here, for those who remember the cigarette lighter in cars. Does anyone actually still use one? There we go, yep. Out of here as well, they're also going up to the main inverter board up there. So there you go, that is a big ass connector right there. I presume that they're just paralleled in there without taking all that out. I mean, it's not like they would, split the battery or anything like that at all. Just be the one big series parallel bank in there, and they're just running separate wires out just from a power distribution point of, wiring distribution point of view. And one goes out to the AC inverter board on top, and the other one just goes over to our main board here. So, well, I can actually measure that. I can measure the ohmsky between those two, and it should be nothing. So let's just do that. But yes, there you go. Yeah, they're just, there might be some extra protection on the board up there. It's probably got some extra protection. As I said, there's some extra fusing up the top here on the mains input. Although this one down here, oh yeah, yep, I see oh yeah, it looks like they just have some SMD fusing there as well, but not as serious as the main side. And it looks like our BMS wiring, although it could actually be on the main board and they might just be tapping these off. This actually just joins into, it's interesting, it goes from this wiring harness into this ribbon cable here via this inline connector here, so that's rather unusual. There you go, it's 10.8 volt pack. That's lower than I thought. 40 amp hours there, 427 watt hours nominal capacity. Not sure what it'd have these days. It's not sure how long I've had this, probably, oh geez, it could be 10 years old. Not sure actually. There you go, we've got 3 extra pairs of switching transistors on the back of that heatsink as well, we couldn't see before. Okay, let's see what voltage this thing is at. I'm going to be very disappointed if it's let itself drain down to something drastically small. Zero? Hello? DC volts? Yeah? Bueller. Well, what's obviously going on here is that some sort of protection board on here, which will have over voltage protection, it'll have under voltage protection and under voltage lockout, which is what it's probably doing here. I mean, there's no electrochemistry reason why this battery is at absolute zero just from, you know, doing this. So obviously it's gotten below a threshold on the battery protection on there where it's literally disconnected the battery to actually protect itself. So at least they did something right, because otherwise there's no way we're going to be reading zero on there. So I suspect, I'm pretty reasonably confident that once we connect an external supply to this thing, that will then overcome that and it'll charge up. But why it's like sort of like doing that hiccup in, I'm not 100% sure yet, but anyway, I'm pretty confident that that battery hasn't like completely come a gutser. I think it's actually protected itself with under voltage lockout, and yeah, we can just should be able to get that started again. But why it can't do it on its own, off its own bat? I don't know. That sucks. All right, everything's disconnected. So let's just plug this in and see if it. Yes, it comes on, stays on. And I'm not sure if you're seeing that with the light. It's flishy flashing at 20% there, like it's doing something, but there's obviously, they didn't design in an error indicator on this LCD, because this is like a segmented LCD. It's not a graphic LCD. All I had was a Raspberry Pi hooked up to the USB here. It should have intelligently, once the battery was low, it should have disabled the output here. Like, what the heck crap design is this? Like, Goal Zero's a pretty big brand. They're one of the leaders out there. Granted, this is like a really old model, but damn, very disappointed. Next thing I want to try here is to hook the battery back up, but I'll leave the inverter up the top, that inverter board, I'll leave that flapping around in the breeze, and let's see if what it does now. Here we go. Yeah, whoa, whoa. Oh, it's doing better. It's doing better. It's flashing better. Are you seeing that? Yeah, so it's flashing differently. It's like hiccuping very differently, almost consistently than what it does before when it had, I guess, the extra load of that inverter board on the top there. Look at it. That's one sick puppy. Oh, I can get in there and measure the voltage. Actually, at the same time, I can disconnect the negative here to see if it's actually attempting to do something. There you go. It's attempting to do something. There you go, 9.3 volts. So it's attempting to 9.34, 9.35. Oh, 9.36. This is not drifting. This is like actually, it looks like the battery is perhaps, oh, sorry, are you seeing that? It is now, yeah, 9.42. If I leave 9.43, come on, you can do it. Yes, 9.44, come on. You can do it. Looks like it's slowly accepting a charge now. So that is good. You know, I can hook on an external lab supply and try and slowly charge it and stuff, but oh, the little rings come off. But it looks like I don't have to. My Band-Aid's falling off. There we go, I'll take that off. Put a new one on before I go to the gym tonight. So I'm going to actually leave that, because I'm just, look, it's permanently on now. Yep, it's permanently on. It is charging. Input, 53 watts, 50 watts. There you go. So it's charging the battery. All I had to do was disconnect the inverter up here. It was drawing too much like peak load when it was coming on, when the battery was flat, I guess, so to speak. I'm pretty confident that, well, that 50 watts has to be going somewhere, and it's actually measuring that using a current shunt on the board somewhere. It's actually measuring the input power going to the battery. So it looks like it's accepted a charge. Just the mere threat of me getting out the big guns, getting out the benchtop power supply and threatening it with a good time, that it's said, okay, I will cooperate and I will start charging. But yeah, that's interesting. So now I expect there to be nothing wrong with this thing. Yeah, it's definitely now accepting a charge. So that 50 watts is going into the battery. No worries whatsoever. So I'll come back in an hour or two, and I suspect what's going to happen is once that battery has got sufficient charge to now boot this thing on like normal, then we can hook up re-hook up the 240 volt mains inverter in there, and then that's obviously taking some surge current in there that the processor or something didn't like, and then it was hiccuping, the actual processor was hiccuping, that's called that flashing that we saw before. It was trying to start up, but that inverter up there had too big an input capacitance on it, and it just didn't like it, and it was like, no, I'm going to shut back down, and then it tries to start up again, and then no, it shuts down again. But because there's very little capacitance in here, for example, very little surge current to charge up when you initially turn it on, the processor in there, the controller, was just happy with that. Now it's cooperating. So, yeah, I think once that's back up in business, I expect to be able to hook that back up, and Bob's your uncle. I think that's our repair. Sorry, another one of my... It's interesting, but I don't think there's going to be an electronics repair here. I think it's... didn't even have to get out lab power supply. Well, I'm going to call that a win. What are we up to at the moment? Oh yeah, 9.91. Come on, you can do it. Anyway, I gotta say, I do otherwise like the construction of this thing. It's a big extruded aluminium case like this. It's very nice with just a cutout in the front, so it's like rugged and these plastic inserts just like slide into here, so they're not gonna come off unless you absolutely like smash them off or slide them up. Same thing with the grills. They've got like big deep grooves in there, so they slide in. So it's a really nice physical design. I rather like it. It's just a shame that they allow the damn thing to like kill itself by draining itself. Like, you had one job. Just turn off once the battery reaches low. Oh, it's not rocket science. Actually, what I'm going to do is I'm going to disconnect that. Oh, that's right. I can't actually switch this off. It's got a light button, but it basically stays on like all the time. Let's see if it's held that. Yes, 9.91 volts. Oh, there we go. Just dropped to 9.90. Maybe, but you know, it's barely even got any charge in it at the moment. So, all right, I'm back from the gym. I got new Band-Aids and they held. So we are at 38%. That's not too shabby. So that looks like it's just charging exactly like it normally would. So that should now have plenty of juice in it. There we go, 11.04 volts, no worries. So I think I'll hook up the AC inverter back, and I think we'll be right. I'll manage the cables again before I put it back together. That is probably like switching the power through. No, that comes straight from the battery. So that's going straight on there, and then they'll have this signal coming from this over here. So we're still good. Let's turn the inverter on. Oh, that's all right. I've got the output disconnected. Output 11 watts. Yeah, it actually draws a substantial amount of quiescent current just sitting there, switching its little pants off. I've got it fed up the clacker there, and oh, yep, there it is, 230 volts. I've got it set for. No, there's 245 volts I get here in the lab rubbish. So that looks like my theory was correct in that, yeah, this thing just went into undervoltage lockout on the battery management, or the battery protection in there. It's not the battery management system. The management system has to do with like the charging and the cell balancing and stuff like that. Still not sure if that's done under there, or because they've got multiple wires coming out here, it might be done by that PIC micro in there. But anyway, that's neither here nor there. So it could not get out of that undervoltage lockout and start recharging itself while the AC inverter was connected, because it had like too much load on it that was just preventing the battery protection in there from coming back on, or the exact mechanism. We don't know unless we've got the schematic and we did further investigation. But there you go. That's an interesting thing. I don't know, like, I'll be generous to them and say it could be the fact that this is quite an old battery. I haven't cycled it a lot, but it is actually quite old. So maybe with its age, the ESR's increased and that didn't give it enough juice, but just to like start up an inverter like this, that's not a massive amount of inrush current, or, well, you know, I don't know. Thoughts in the comments down below, but geez, let that be a lesson to you. When you're designing a battery like this, make sure you actually design it to be drained down, and then like absolutely abuse the heck out of it. And then like I would use like really depleted age batteries on the thing as part of the testing, and part of the design testing for this thing, to make sure that, yeah, it can actually start up and charge again. But the damn thing couldn't with that load on there. But once I removed the AC inverter load, Bob's your uncle, and she was able to recover. So maybe they could have had the undervoltage lockout just set too low and it just didn't have the juice available to do it. But I know, given that this thing does not have an actual power switch, I kid you not, right? That LCD, like you can probably see it, that LCD is still on. So that micro is still running, the LCD's still going, but granted that could take, you know, like microamps, right? Tens of microamps just to keep that the small segmented LCD going. So it didn't take a lot, but ultimately, you know, could eventually drain down. But granted, like I was using the USB-C output on here, but this, the micro here, this PIC micro should have determined that, oh, okay, battery, like, you know, should get low battery and then shut off the USB output here, where I don't think it did. I think it just kept it on. Like, I wasn't there to watch it in real time, but I could test that, but I'm not going to do it in this video. But yeah, I assumed that it just kept pumping out and powering my Raspberry Pi, doing the absolute best it could to power my load, and it didn't shut down and preserve itself, and it completely kamagutsa, couldn't restart. So yeah, that is a fail in the design of this thing. So there you go. That is not an electronics repair, but that is interesting nonetheless. So if you did find it interesting, give it a big thumbs up, as always discussed down below, and over on the EEVblog forum, of course, the best forum on the interwebs. And if you want to get my meters, you can get those on eevblog.store. Catch you next time.